Hello. 1 minute early. I was just looking up and down different implementations of USB host, seeing how many state machines they need. And I might run out. Don't know. Might not be able to use everything that uses a PO state machine at the same time. So for example, if you're using the I2S, DAC and ADC, that might be two PIOs, and then you might not be using the USB host and the SD card at the same time. But then again, the only things that really need the PIOs are the I2S devices. The SD card can run just off SPI, just a bit slower. There's just enough to run those three things at the same time. But say if you wanted fast SD card, you might have to disable something else. But then in your program, depends on your program, doesn't it? Anyway, this video, just a recap of what we're doing. I'm designing a open source module that's designed to be completely assembled, jacks and all, at JLC PCB. I'm currently just trying to get all the chips in on this board on the left here, which is sort of the brain board, which goes on the back, and then there's a connectors board that I'll probably start on next. Today is going to be my last day this week that I'll broadcast, and then I'm probably not available till Tuesday night after that. But I do really want to order next week. I'm not sure if I'm going to get there. Yeah. So I'll just get going. I don't know. Yeah, so what I was doing was, I've moved everything roughly in the right place. And I think I need to jig around some more bits and pieces to line up with the connector, just to make it a bit easier. Because what did I notice? These are the logic inputs, gate input comparators, and they go to MCU gate. Wait, what? MCU gate in 2. No, they don't. They go to gate in 1 micro, gate in 2 micro. It's all the way up at pin 7. No, that's pretty good place for them. So it's gate in 1 micro, gate in 2 micro, MCU, oh no, wait, CV gate 3, CV gate 4, in 5 and 6, yeah, that's great. Wait, I did that on purpose, didn't I though? The only question is then after that it goes up to MCU gate 3, 4, MCU gate 1, 2, which is pin 55 to 58. Yep, it's on the other side. Handy if it was somewhere like here. 1, 2, 3, 4. But then that is DAC. The DAC stuff, which is on the side anyway. And the audio's ins and the audio's outs are 1, 2, 3, 4. Oh, brilliant. It's all on the same side. The only tricky thing is I've got to get the gates across. Yeah, and I can't put them where the HSTX stuff is because that's a fixed peripheral. That seems fine to me then. On this side, got the CV outs, and they're on. Wait, what are these? Oh, these are the CV outs. That's what those are. What's this one? Oh yeah, and this leads to those. It's got its own dedicated power supply, but we've got to also fit in this lot of stuff, which is the CV inputs. CV input is CV gate in, CV in 1, 2. Kind of all over the place. 15 and 16, 5 and 6. In the middle, but that's kind of good because maybe I'll stick it up there, so I might just move this. So it's still close to pin negative 12 pin, but get this stuff squished down a little bit. I still think these capacitors are too small. And then this is our DAC. Gotta lock that because it's annoying. Nope, still selecting it. I thought I was locking it. Oh. Yeah. This can actually go like this. Now I can move in these op amps. Just not enough space. Is that centralized? I don't even know. Well, ish. It's pretty centralised. Just wondering how to get this down a little bit. And this is where it's going. This is what this regulator's for, so it's probably quite good to stick it right next to where it's aimed at. Oh, but that's 12 volts input. Just a little bit too big to fit in. This stuff doesn't have to be here though. This can move up very slightly. This one, decoupling cap, and just put it like there. Wait, no, but it's for 3 volts. Wait, what's that for? Why is that one connected to 3 volts, and why have I got its capacitor over here? That one's connected to 3 volts. Oh no, that's, yeah. So the input of a comparator can be up to 36 volts, so its inputs are tolerant. But it has ESD diodes. So is that a problem? It says input differential voltage could be up to 36. I mean, there's no reason they could be connected to any voltage because the output is an open drain. And I'm using the internal pull-up inside the microcontroller. Try and clear up all the bits. Ah, definitely need to put them in. Here with our protection diode. They go up to 13 and 14, so they need to be somewhere near the middle. So this would be a beautiful place for them. Do they need decoupling caps? Do they recommend it? Yeah. I mean, most most manufacturers do, and they recommend it for both rails. I think before I properly publish the designs, as in submit them to be open source or whatever, certified, I will give the schematic a really good clear up. That. I'm leaving a little bit of a gap in the middle because I need to come up with a solution. I haven't really decided yet how. I think the idea was to use a socket in reverse. So you can get these a socket version of these, and you can actually stick a connector through it. A connector through it from the back. It's a bit of a hack. What button's this? This is our menu button. Menu slash boot mode button. Oh. See, I'm now starting to get everything in a neat place, and then we just have to go over it and over and over it again until think I can put that over the USB line because there is a ground port in between. These are associated with that EDC. These are pull-ups for the DAC. So it just goes in between the micro. So I could actually put them close to the... I could put them here. I don't think it matters too much where the I2C pull-ups are. Gives us more space down there. Then what are these? Oh. This is going to go... Oh, that's for the reference voltage. There. So it's that. What are these? These are more things that go... Don't really know if this is good practice. I just had a thought that, like, if I put beads before the ribbon cable, as you can see, I'm pretty clueless about EMC. Going to double check something. Double check the stream. Sorry, extra boring today. There you go. I've got everything on the main board. Now, what I want to do is try and make sure everything that's spaced. I might make a new view. Sorry, I'm live OBSing. Oh. Don't know why that doesn't fit. Wait, how do I make... Weirdly, this doesn't fit. Anyway, now I'm just going to go over and over and over. Sorry for making you feel funny with doing that all the time. What would be best to do now? Look at it from a 3D view. See, that's kind of how it's looking now. Looks neat in the picture. When you see all these rat's nest wires, it's a bit of a different story. I might just take that out again. Looking at this could be (18). Press this all down a little bit, you see. There isn't much to the DAC. Made a huge difference to shrink those resistors down. What are these for? I think those are a bit big. They're not they're audio, so it's probably quite good to make them small anyway. So C10 and C9 should be 0402. Wait. Wait, where are they supposed to go? They're supposed to be going into pin 14. Ah. It's not, this needs all pulling over this way. Makes sense to put it here. Low pass filters. They're the ones that just shrunk down. They need to go to R15 and R16. Oh, that's... What? Wait, this is... Yeah, that's the output. These are for the input one. Oh, so they go over this side as well. What's this one for? Pin 4. Might as well do sort of something like this. This seems a bit mad. Maybe they should just be smaller. These maybe near 1 and 2. This is maybe 1 and 2. This one goes into 2. Coupling cut. Which one though? That one. This one goes 2, 6, 7. Into 6. This goes somewhere where U10 is. I'm going to first determine whether it's a good idea to have ferrite beads, and then I'll search if there's some kind of multi-package you can get. This is quite funny, the HSDX. How would I route that? Will I start? I'll do it inside. So would I... I'll use my wires. Have to go like that. Then inside, probably don't want to go too close to this, and also this. The paw is way too chunky. I have locked it. Could be even smaller, but I kind of want to. Which one? So it goes 17, 16, 15, 14, 13 goes that, and here it goes 17, 16. Yeah, that seems good. Probably do it. Got to go round. I don't want to go near the. I'd rather go a long way than anywhere near the switching supply with this, because it's not important. I'm never going to be doing DVI. I'm just trying to use. Oh, what? Doing the wrong order. 17, 13, 12, 6. What the hell? What? Oh. I rearranged them, but I shouldn't have done that. Should be 17, 16, 15, 14, 13, 12. And I've got to rearrange these to DC goes there. Oh, what's SDA, DN, CS, and clock, res, reset, chip select, DC, clock, DN, reset, blank. Now these are all wrong. These are all wrong as well. No, they're not. I need to put shove on. It's a bit annoying. It looks a bit odd, but there is a ground plane between them. Oh, that's annoying. Look at that. Oh. It's making my CPU set on fire as well. Fan blowing hard. Oh, what a mess. Shove is a bit annoying. Just want it to be neat and compact, not fragmented. Like that. There we go. That's mad, but okay. I'm kind of getting ahead of myself. I really should just be doing the power. Just think about how to get power. Ideally, power should be mostly routed on the top. Maybe. If I click on this 12, these are where all the 12s are supposed to be. It's quite a nice line. So I could actually just... Would 2mm be too big? No. Could I run the 12 just down like that? It comes from the here. Messy. Maybe it's a bit ugly. I don't normally do it like this. Oh, that one just runs off 3 volts. Oh, but that's got its own power supply. Quite a nice short range, like 12 volts. It'll go into the chip and then it'll probably run back again. The big ground plane has to run back up here. Oops. Why is it over here? Oh, there's another 12 volts here. Okay, that's dodgy. strategy I'm doing, which I'm not sure is going to work, but it's just to try it out, is prioritising power supply on the top layer. Because quite often I would do Manhattan style, where I just trough it up, but seeing how it works out. So I've got some interesting things, like for example this chip has its own dedicated linear power supply. Oh, I haven't done -12 yet. Where's the... rotate this around. Pretty much the same. It's quite cool that it... The only problem is they've got all these beads here. Actually, let's see what I've done. I mean, it's not a lot of current. There's not really a desperate need to have a huge track, really. You know what, there's no reason it has to go through the middle. And then what other power supplies are there? The one that's for the 3 volts. Oh, it goes all over the place. I just realised my comparisons aren't going to work if I'm running them off. If I'm running them off 3 volts, I don't know why they're running off 3 volts. That's bizarre. Might as well just run them off 12 volts. Why are they not? The output is an open collector, so I don't see. I'll have to probably adjust this. There's no reason to pull that voltage all the way out. I have to tweak this voltage divider. So now these are 12. And obviously those are 3, but could my logic level converters, could they run from something else? Could they use the 3 volt logic from Nah, it's alright. I'm going to get sidetracked now. I realise I haven't wired up my memory. Wires don't have to be that big. How am I going to do it? Problem is I've got this USB. I guess I could pull those down. And then these can go into wires. Something like that. They're supposed to be as short as possible. This one needs to be first. Don't know how that's going to get in. Oh, I missed one. Needs to go in between these guys. Messy. I might need to also check my clearances. And see if I can get these to squish together a little bit. Nope, not easily. Me. It's a bit terrible. I'll have to see how that works. Ground is just wire. That's it. Then I've got to try and connect. This is a very messy way to do it. But there's not much else, because they're right on the board on the edge, there's not much else that's going to get in the way. Oh, might have to do a via there. Kind of limited myself a lot by using just the one layer as the signal and the top as the signal as well, because the top you always want more layers though. Right, what should I do next? We should really have a look at this power. I was going to look at this TPS 54302. I'm going to use the datasheet for tips, because usually they have a layout guide at the end. Sorry. Yeah. The VN and ground traces should be as wide as possible. VN is 3. I feel like it needs to be the other way around. I mean, do I just make a ground pour that starts somewhere here on the front layer for 12 volts? There's no need to have the 3 volt over this side. Then I feel like the capacitors are too small. This guy, I've only got 100N. Oh. Got a big electrolytic and I've got 100N. I think I'll definitely also benefit from having a chunky I've got enough space for it, and I think I'll benefit a lot from having a big chunky 10 UF cap here. Be connected by wires. Maybe the other way around. Sort of no need for this to be so. Just down there. The voltage divider should be as the VN ground should be wide as possible, reducing impedance. The wide areas also help voltage to form a point of heat dissipation. The incapacitor and the outputs should be placed as close as possible. Where's our output capacitor? Oh, they're all here. We've got a big. That one doesn't have to be close because it's just a bulk cap. But it'd be good if this one wait, but that's wait, what's this way? Yeah, that's that. Oh, it's after the inductor. Then there's this one, and it should probably be pretty close to 6. And it goes to 2, so I'll put it like there. Where's the inductor want to go though? The inductor wants to go to 6 or 2. Ah, that's why I have it down here. Why? Okay, so this should be the other way around. Voltage divider should have the smallest possible distance, so it just goes there. Oh, the boost capacitor provides sufficient wires for input output. Keep the switch trace as short and wide to minimize radiation to the pattern. Which one? The switch trace. But the switch trace has to go to the they're in Dutch with imaginary. It's kind of weird. Do not allow switching current to flow under the device. Okay. Separate V out path. Should be connected to the upper feedback resistor. Make a Kelvin connection to ground. For the what? What does a board layout even mean? The voltage feedback loop should be placed away from the high voltage switching trace. The voltage feedback loop. The trace of the voltage feedback node should be as small as possible to avoid noise coupling. That's feedback there. The ground trace between the output capacitor and the ground pin should be as wide as possible to minimize its impedance. Yeah, sure. Sure, mate. The main thing I've got to do is make sure this which one switch is to the switch. Yeah. So maybe we'll put 2. Maybe we'll make a nice layer for net U12. U12. Why can't I see it? Oh, it's called something else. Yeah, it's called net. I'm looking for U12 switch. Oh. U12 switch. And I want it on that layer. Huh. Guess I'll just do that. Kind of random. That I'm avoiding going under. Let's put in some wires. kind of, nah. That's sort of what it's asking for. I think that inductor's too big. And then pin 5 is just enable. Sure, that can go under. Oh, and I haven't done the wires for this. You know, it's got a trace. Is that a trace? And it says to put the, it says a separate VR path should be connected to the feedback resistor. I guess that's that thing where you let's just do this. Got a little strange 3-volt island coming under. Maybe just put a keep out there or something. There's kind of no point in 3 volts coming over here. Should probably do that. Now it says, I think that's all right. What you might do is you might disconnect that there and then have a trace that goes under to the first point of output, but it really doesn't matter. And I've got these capacitors. What's this one for? Oh, it's just general. I'll put them up like that. And these can all have this for? Six and 2. Why is 6 not connected? Oh, right. They have it going from 6. Boost capacitor. They have it quite chunky. really sure what the boost capacitor does. The main current comes out the switch, I think. What does boost do? Supply input for the high side NFET gate driver circuit. Supply input. Is there an internal schematic? I think it's just like a internal circuitry power supply. Sure, I could just do this. But it's through a capacitor. That's confusing. Okay. What's that look like? Funny. It's not really space efficient, but I don't need to be. These can just go like this and sit right over the 5-volt output. It gives a nice kind of continuing the theme of using multiple mini wires. What's this one for? Pin 4. If you look at the green layer, that's where all the grounds are just kind of got this nice clear space, but it'll probably go, yeah, I don't know. I also realised I put in debug port, But I don't have the serial debug. Oh no, I don't have any GPIO left. No, that's a shame. You can't do serial debug. But you can do it over USB. What's this one for? Ah, a voltage reference. What I can do with that actually. Oops. Takes the 5 volts that I've generated here. Get nice and close there. There's kind of no point in this one. Because it already has one next to it. Ref 3033. I think I just chose this one because it was cheapest. Not cheapest, most common. You can take up to 7 volts in, or the recommended. Don't know. Do they recommend putting a capacitor? Yeah. I probably should just move that capacitor. I think it's good practice to put, especially when you're trying to make a stable voltage. And I've got tons of space. And then it's got to connect to this op amp here, which I should exchange for a better op amp, but for now I'll just put this in. That's perfect. I'm not using the 1, 2, 3 part of it. So 1 and 2 just connect to each other. Ground. Via. And do it via. Do it on the outside just in case I want to cut it. Then this resistor goes between 6 and 7. This one goes into 6. What are these? These belong to the chip. That's good. Look, my ADC comes in there. This goes 6. 7 just goes up there. Oh. And that's just the reference out. Oh, beautiful, and that's it. Going into my microcontroller. Such a nice short journey it goes on. Great. I think I'm going to call it a day there. I've got quite far organising things. I'm not totally sure about this whole, it looks ugly to me, this whole having the power go up like that. Don't know. I should load the 3D files for these in to get a good feel for it all. The crystal and the, where's the power? Where's the yeah, there it is. The switching stuff should be pretty much exactly how it is, as specified. Yeah. Oh, actually, one last thing out of curiosity. Can you get a ferrite array? That a thing? Dips. I guess you don't want them touching each other, really. You do get a ferrite arrays. What do they call the package? It's called a ferrite bead array. Oh, number of circuits. What if I did 8? Well, that's rare. If I did 4, yeah, they're really common. I need to select one though. That could be handy. Great. What I'll probably also do is I'll go all over the capacitors and double check where I might want to make them more chunky because of capacitor derating, as I've talked about a million times, bored you with. Alright, great. Thanks very much. Bye.